unitary matrix, we have seen that unitary matrix A is a square matrix. A square matrix A is unitary if and only if A into A theta into A is equals to identity matrix, right? Or else sum of squares of moduluses of elements of any row, any column is equals to 1, and sum of products of any elements of any row or column with the conjugates, corresponding conjugates of another row or column zero. So this we have seen. Of course, we have seen the properties. Sum of unitary matrix may not be unitary, right? That we have seen, right? And product of unitary is unitary. Now my question: if take A is unitary, right? If you take any scalar, does it mean that K into A is it unitary? Right? Is it unitary? So let us go for the product. K into K whole theta. That means K into K bar A theta. That means K into K bar into A theta. That means K into K bar is nothing but mod K square. A into A theta is nothing but what? I. Right? Because A is unitary. Similarly, Ka theta into Ka is nothing but K bar into K A bar A theta into K into A. That is same as saying that K bar into K into A theta into A, that equals to mod K square into I. Therefore, both are same. Therefore, it is unitary. That means, in general, what you say? In general, scalar product of unitary matrices, is unitary. So these properties are, already told you, these properties are very, very useful when I deal with vector spaces, subspaces. Understand? So generally, if I take this matrices, suppose you take a set of all unitary matrices over a field F. Question is it a vector space over a field F? The answer no, right? The answer no, right? Because we have seen that sum of two unitary matrices may not be unitary. Understand? Sum of unitary matrices may not be unitary. Therefore, it is not closed with respect to vector addition. Therefore, it is not a vector space. Right? These properties are very, very useful when I deal with vector spaces. Right? Next is, so scalar product is over. Next is, suppose A is unitary. Suppose A is unitary. Right? What is its determinant? What is its determinant? Right? So A is unitary means A into A theta into A equals to identity matrix. That is a unitary definition. Now what you do is that take the determinant on both sides. Det of A theta is equals to, in particular, det of I. Right? Det of I. So det of A theta is nothing but det of A into det of A theta. Det of I is equals to 1. That means det of A into det of A theta is nothing but det of A bar What is A theta definition? A bar whole transpose. So det of A into det of A transpose is nothing but det of A. Det of A is equals to det of A transpose. Is a property, right? So det of A bar. So det of A into det of A bar. This is also another property. Det of A bar is nothing but det of A whole bar. This is a conjugate. Det of A bar is equals to det of A whole bar. That means, what is this? Det of A whole bar. That means det A into det A whole bar is nothing but 1. We know actually z into z bar is equals to, what is this? Mod z square, whenever z is a complex number. Right? So here, what is det actually? Det is actually a scalar. Right? Scalar. So scalar into the conjugate of itself is nothing but actually 1. That means what? Modulus of det A whole square equals to 1. Right? Modulus of det A whole square equals to 1. Is it right? Is it right? So modulus of det A whole square equals to 1. Right? So therefore, modulus cannot be negative. So det of modulus of det A equals to 1. Modulus of det A equals to 1. Right? So therefore, modulus of det A is 1 means what? Actually, modulus, if 1 means 1 is non-zero. Therefore, in complex analysis, any non-zero complex number, you take any non-zero complex number that can be represented as a polar form, r into e power I theta. For some r non-negative, and for some r positive, because actually I started with non-zero, and for some theta is right. So therefore, that means what? Actually, this can be rewritten as, here r is nothing but actually what? What is my r? What is my radius vector here? 1 into, what is my distance here? 1 into e power I theta for some theta. So therefore, det of A, whenever A is a unitary matrix, we take A is always e power I. This is very powerful technique. Very powerful. Is it clear, the concept? Is it clear, all of you? Suppose we take this. So if A is a unitary matrix, then which of the following is true? First one, A, det of A is equals to 1 plus 2i. Det of B equals to 1 by root 2 plus I into 1 by root 2. C, det of A equals to e power I theta, right? Theta is a real number, and D is equals to det of A equals to, right, 1 by 2 plus root 3 by 2 I. Yeah. Now tell me which is possibility of det A. So this is not possible, this is not possible, because whenever it is unitary, we are given, actually it is a unitary matrix. A is a unitary matrix. As A is a unitary matrix, det A is nothing but e power I theta. Right? That means it should be in a unit circle. Right? What is mod of this? What is mod of this? Whenever A is unitary, mod of det A is nothing but 1. We have seen. Whenever A is unitary, mod of det A is equals to 1. But what is mod of det A here? Mod of det A is equals to 1 plus 4. Is nothing but root 5. This cannot be 1. Therefore, this first option is false. right? Similarly, det of A for option 2, mod of det of A, that is nothing but what? Under root of 1 by 2 plus 1 by 2. That is nothing but what? Under root of 1 by 4. That is nothing but what? 1 by 2. This cannot be 1. Therefore, option 2 is false. Next, mod of det A is nothing but mod of e power I theta. Again, it is nothing but 1. Therefore, this answer is right. Similarly, what is this? Mod of det A is equals to under root of 1 by 4 plus 3 by 4, that is equals to root 4 by 4, that is equals to 1. Therefore, this also is possible. So what are answers?
Second one.
B is also correct, sir.
1 by 2 plus, yeah, this is 1 by 2, this is 1, right? Sorry, this is 1. So this is also right. This also right, right? So therefore, this is what actually importance of unitary. So det modulus of det A should be 1. Whenever A is unitary, modulus of det A should be 1. Right. Next is normal matrix. Right. So you started with a square matrix. Start with a square matrix. Then it is said to be normal. If and only if A into A theta into A, that's it. A into A theta is equals to A theta into A. There is no shortcut for this because actually there is no identity matrix here. Therefore, there is no shortcut for this matrix. Therefore, A is normal if and only if A into A theta is equals to A theta into A. Therefore, you can give some examples. Suppose you start with a problem. A is equals to 6 minus 3 and 3 comma 6. Right? So is it unitary or not? So what you do is that you start with A into A theta. What is A? 6 minus 3, 3, 6. What is A theta? Anybody? A theta is nothing but, what is the definition of A theta? A theta is nothing but transpose of A bar. Right? First, you take the transpose and you take the conjugate and take the transpose. Right? Transpose and conjugate. These are real numbers. Understand? All are real numbers. So conjugate itself. Therefore, 6 into 6. What is this? 36 plus 9. Right? 18 minus 18. Next, 18 minus 18. Next, 9 plus 36. Right? This is nothing but what? 45, 0, 0, 45. Similarly, A theta into A. What is this? What is A theta? A theta is nothing but 6 minus 3, 3, 6. What is A? 6 minus 3, 3, 6. Right? So therefore, 36 plus 9 minus 18 plus 18 minus 18 plus 18, 9 plus 36. That is nothing but 1, 45, 0, 0, 45. So what you observe is both are same. A into A theta into A equals, both are equal. Therefore, A is normal matrix. Right? Similarly, you can check this. So can you give example for not normal matrix? Suppose you can take this. A equals to 2, 5, 3 minus 1. So A into A theta is A. A is nothing but what as it is, matrix itself, 2, 5, 3 minus 1. And what is this? 2, 5, 3 minus 1. It is a real matrix. A theta is nothing but itself, A transpose itself, because A is a real matrix. A is a real matrix. Understand? A belongs to R2 cross 2. Understand? Therefore, A theta is nothing but itself, A transpose. Therefore, this 2, 5, 3 minus 2. Therefore, 4, 25. Therefore, 29. 6, 6 minus 5, 1, 6 minus 5, 1. 9 plus 1, 10. Similarly, d theta into a, what is this? 2, 3, 5 minus 1, right? 2, 5, 3 minus 1. Therefore, what is this? 4. This is 5, no? 2, 3, yeah. 4 plus 9. What is this? 13. Next 10 minus 3, 7. Next 10 minus 3, 7. 25 plus 1. 25 plus 1 is nothing but 26. So are they equal? No. A into A theta should not be same as saying that A. Therefore, A is not normal. Right? Now, suppose you take another example with the complex numbers. A equals to 2 plus 3i to 1 I and 1 plus 2i. Right? First of all, what is A theta? Anybody? A theta is nothing but what? Conjugate. First of all, take the conjugate. Conjugate is nothing but minus I. This is 1 minus I whole transpose. That means 2 minus 3i, 1 minus I, 1 minus 2i. Right? Therefore, now we compute A into A theta. This 2 plus 3i, 1 I, 1 plus 2i. Mute. Somebody mute. Mute the mobile. So 2 minus 3i minus I, 1 minus 2i. Right? So 4 plus 9, 13. This is nothing but what? Z bar. That means what? Under root of. So modulus of z square. That means what? So 2 plus 4 plus 9, 13. 13 plus 1, 14. Next, what is this? Minus 2i, minus 2i, minus 3. Right? Plus 1 minus 2i. Right? So minus 2i, minus 2i plus 3. Sorry, minus 2i plus 3. Right? Next, 1 minus 2i. Next, 2i plus 3. 2i plus 3. Next, 1 plus 2i. 1 plus 2i. Plus 1 plus 2i. Next, 1 I into minus I is nothing but 1. This is nothing but what? Plus 5. 1 plus 2i into 1 minus 2i is nothing but what? Mod z square. That is nothing but 1 plus 5. That is nothing but what? 14. Minus 2i minus 2i minus 4i plus 4 is nothing but what? 4i plus 4 is 6. Similarly, one can compute A theta into A. What is A theta? You know what is A theta? 2 minus 3i minus I. Next, 1 minus 2i. Right? Next, 2 minus 3i minus I, 1 minus 2i. 2 plus 3i, 1. Next, I, 1 plus 2i. I, 1 plus 2i. So that means it's nothing but 4 plus 9. 4 plus 9 is 13. 13 plus 1, 14. Next, 2 minus 3i. Next, minus I plus 2. Right? Next, 1 plus 2i. Next, plus I minus 2i into I plus 2. Right? 1 plus. So this mod z square, that is nothing but 5. That is nothing but what? 14. 4 minus 4i. Next, What is this? This is nothing but 2, I know. This is somewhere we have done a mistake. This is 2 minus a theta is nothing but what? You right? This is nothing but what? 1, 2 plus 3a, right? This is 3a, right? Right? Therefore, 4i plus 4, this is nothing but 6. Therefore, both are same. What you observed is both are same, hence it is normal. Right? You can easily compare. See, there is no shortcut for this because actually there is no identity matrix. There is no identity matrix. So therefore, there is no shortcut for this. Right? Next is sum of normal matrices. Again, properties. We start with normal properties. We take A is a normal, B is normal. That means both are normal matrices. Does it mean that sum is normal? So the answer in general no. So let us take a matrix. Suppose A equals to 0, 1, minus 1, 0, B is equals to 0, 1, 1, 0. Right? So first you need to check what is A into A theta. A as it is 0, 1. First you need to check whether they are normal matrices or not. First you need to check. So 0, 1, minus 1, 0. And what is A theta? A theta is itself A transpose because it's a real entries. Therefore 0, 1, minus 1, 0. Therefore 0 into 1, 1. 0 into minus 1. This is 0. Next 0. So 1. Right? Next A theta into A. Right? What is A theta? 0, 1, minus 1, 0. Next A is nothing but 0, 1, minus 1, 0. Therefore, this is 1, 0, 0, 1. So both are same. A into A theta is equals to A theta into A. In fact, this is an orthogonal matrix because it's an identity matrix, in fact. Therefore, it is normal. Right? Similarly, you can check that B into B theta. What is B into B theta? This is B is nothing but 0, 1, 1, 0. You know, what is B theta? 0, 1, 1, 0. Right? 0, 1, 1, 0, 0, 1, 1, 0. Right? Therefore, you know, it is a symmetric matrix, right? So therefore, once you take this, you are getting the same entry. Similarly, once you compute B theta into B, again same entries you are going to get, same matrices, same entries. 1, 0, 0, 1, 0, 1, 0. So therefore, both are same. Therefore, B is also normal matrix. It is a see this matrix and this matrix both are same. This matrix and this matrix both are same. So once both are same matrix, the product is same. Therefore, it is normal. Now my question: A plus B. Compute A plus B. What is A? A plus B is nothing but 0, 2. Next 0, 2, minus 1 plus 1, 0, 0 plus 0, 0. Right? Minus 1 plus 1, 0, 0 plus 0 is 0. Right? Next question is it actually normal? Compute A plus B theta. What is A plus B? 0, 2, 0, 0. A plus B theta is nothing but 0, 0. That means 0, 4, 0, 0, 0. Next A plus B theta into A plus B. That is equals to what? 0, 0, 2, 0, 0, 2, 0, 0. That means it is 0. So it is different from the first entry. Both are different. First entries are different. Therefore, it is not normal matrix. Understand? No need to compute all entries. Right? 0, 0. That is 4. Sorry. 4. Sorry, this is 0, 0. Sorry, this is 0, 4, So therefore both are different. Therefore a plus b theta into a plus b, that is not equals to a plus b into a plus b theta. Therefore it is not orthonormal. It is not normal matrix. Not normal. Therefore what you observe is sum of what you observe. So in general, sum of normal matrices may not be normal, right? So what is the problem? You look at the problem. Suppose a and b are normal. That means a into a theta is equals to a theta into a, and b into b theta is equals to b theta into b. Right? Look at the sum. A plus b into a plus b theta. Why it is not normal? Why the sum is not normal? So a plus b is a theta plus b theta, right? That is nothing but a into a theta plus a into b theta plus b into a theta plus b into b theta, right? Right? So therefore, now compute a plus b whole theta into a plus b. What is this? A theta plus b theta into a plus b, that equals to a theta into a, right? Plus a theta b plus b theta into a plus b theta into b. So there is no problem with this entry and this entry because these two are same. These two are equal because it's a normal matrix. There is no problem with this first and first because they are same. What is the problem? Middle portions may not equal. But if you take the condition, a plus b theta into a plus b equals to a plus b into a plus b theta, both are same. If you provide the condition, this equals to this, that means a b theta is equals to b theta into a, and middle piece, another middle piece, that means b into a theta is equals to this one, a theta into b. If you provide this condition, then sum is normal matrix. In general, sum may not be normal, but if you provide this condition, the sum would be normal. Is it clear? Hello? Is it clear, Andy?
Okay, sir.
Right.
Okay, sir.
So next is product. Suppose you take A and B are normal matrices. Question is that does it mean that A into B is normal? So now look at the definition, right? What is a normal? A into A theta into A, right? Similarly, B into B theta into B, both are same. But look at the product. I'm going to check whether A into B is normal or not. So AB whole theta. That means A into AB into, what is this? B theta into A theta, right? Right? Next, compute B theta, AB whole theta into AB. What is this? This is B theta into A theta into AB. Now tell me, are they equal? Are they equal? So there is, this can be rewritten as, so are they equal in general? In general, they are not equal. This is AB into B theta A theta. This B theta into A theta into A into B. So both are in general, both are not equal. Right? In general, what you observe, in general, these two are not equal. This is AB into B theta A theta, and this is B theta A theta into ABs. Matrix multiplication may not be commutative. If you give me two matrices which are not commutative, which are normal matrix, whose product may not be normal matrix, because matrix multiplication is not commutative. In general, not commutative. So therefore, what is my notice? My notice is product of Two normal matrix. May not be normal. Now question, can you give me condition in such a way that whose product is normal? Anybody? Can you give me condition? Can you give me any condition whose product is normal? Anybody? ఏదైనా కండిషన్ ఇస్తే నార్మల్ అయ్యే ఛాన్స్ ఉందా ప్రొడక్ట్స్?
A theta b theta is equal b theta a theta.
A theta
B theta is equal b theta a theta.
A theta b theta is equals to A theta b theta. Okay, that is a one condition. That means that is one good. Who said? So AB is normal if you provide A theta b theta is equals. That means this last are same. Already you know these two are equal. If you provide this first and last, if you provide these two are equal, the answer is over. It is same as saying that, you know, take that theta on both sides. That is it. Same as saying that, you know, what is this? B theta, O theta, A theta, whole theta, means A theta, whole theta, B theta, whole theta. That means if and only BA equals to AB. That means if two matrices which are normal, which are commutative, then the product is normal. Is it clear? Right? In general, may not be commutative, but the thing is, if you provide a matrices which are normal matrices which are commutative, then the product always normal. That is what actually think. Right? Next. What about scalar product? What about scalar product? Take K is any scalar is normal, right? Does it mean that whose scalar product is normal? Then sir, look at the definition. What is A normal? A into A theta into A. Both are same. So K into A whole theta. That means what? K into A. K into whole theta means what? K bar into A theta. You know, this K into K bar, A into A theta. That means modulus of K whole square, A into A theta. So again, you compute it, K into A theta into K into A. That's it. That is nothing but K bar into A theta, the K into A. That means K bar into K, A theta into A. Therefore, this is nothing but mod of K square into A theta into A. That is same as saying that mod K square. You know, A is normal. Therefore, A theta into A is nothing but A into A theta. Therefore, these both are same. Therefore, K into A is normal. This is true for any scalar. That means what you observe? What is your notice? Scalar, any scalar products in general. Scalar products of normal matrices is always normal. Right? This is my notice. Right? Now question is, what is the integral multiples? Integral powers. But K is normal. Right? What about A square? What about A cube? What about A power K? Where K is a positive integer. Right? Now look at this question. You know, A is not what you are given is that A is normal. Therefore, A into A theta into A, both are same. Now look at A square into A theta. A square into A square whole theta. A square into A square whole theta. Right? You know, what is this? This is A square into, what is this? What you've seen actually just now, look, observe the property, you know. So whenever A and B are normal, No need to compute it. Whenever A and B are normal, whenever A and B are commutative, then AB is normal by previous property. Right? A and B are normal, and provided A and B are commutative, then A into B is normal. So here, A into A, actually both matrices are same, therefore obviously commutative. No need to compute this. No need to compute this. Understand? A is normal. Of course, A is normal. A square can be written as A into A. A is normal. A is normal. Therefore, this matrix multiplication is commutative because both matrices are same. Therefore, it is normal. Similarly, what is A cube? A cube is nothing but A into A square. As you seen that A square is normal, A is normal, and these both are commutative. Therefore, it is normal. Right? These both are commutative. A into A square is equals to A square into A. Both are same. Right? So similarly, by induction, A power K is normal. That means integral. What is in general? What is in general? In general, integral multiples, integral powers, not multiples, integral powers of normal matrix is always normal. Right? So this is what actually property. Right? Next is look at the transpose. Look at the transpose. Suppose A is normal. Right? A is normal. What about A transpose? Does it mean that A transpose is normal? So as you know that A is normal, therefore A into A theta into A, both are same. Now take the transpose on both sides. That means A theta whole transpose, A theta reverse product, reverse law for product, A transpose, A theta whole bar. That means transpose of A theta is nothing but A transpose whole theta into A theta. A theta is into transpose of A theta is nothing but so transpose whole theta. So therefore, we observe that A theta for A transpose whole theta into A transpose equals to A transpose into A transpose whole theta. Therefore, A transpose is unitary. So what you observe, transpose of in general transpose of unitary, not unitary, sorry, normal. Did I mention normal or unitary? Sorry, normal. Right, it is normal. Therefore, it is transpose of normal matrix is normal. Right. Now, what about data? So there is no actual conclusion for data. Suppose A is normal. What about its data? No conclusion, right? Why? A normal means A into A theta into A. What is this? You take data on both sides. Is there any conclusion? No conclusion. Data into data theta is equals to data theta into data. Is there any conclusion? Data into data bar into data. Is there any conclusion? No conclusion. Right? So can you say that it is non-singular? No. Can you say that it is non-singular? No, need not be. Suppose you take A0, a zero matrix. Suppose A is a zero matrix. Is it a normal matrix? Yes. Because A theta also zero matrix. A zero matrix means what? A theta also zero matrix. A theta into A theta into A is equals to 0. Similarly, A theta into A also 0. Therefore, it is a normal matrix. Any zero matrix is a normal matrix. So what is the data? 0. Does it mean that it is singular? No, it is not. It is a singular matrix. Is it non-singular? No. Therefore, there is no conclusion. Understand? Suppose you take A is an identity matrix. Is it normal? The answer is what is A theta? The same matrix. It's an identity matrix. I theta is equals to I itself. Therefore, A into A theta is equals to I. Similarly, A theta into A equals to I. Therefore, both are same. Both are same. Therefore, it is normal. What is the data here? Data is nothing but data. Data is nothing but one mat. One is non-zero. Therefore, A is non-singular matrix. In this case, A is non-singular. In this case, A is singular matrix. Therefore, there is no conclusion for data. Right? In previous problems, when you go through the unitary matrix, it is always non-singular matrix. It is invertible matrix. When you go through the nilpotent, it is in singular matrix. When you go through the idempotent, data can be 0 or 1. Right? So, but there is no conclusion from here. When you go through the orthogonal matrix, what is the data? Data is equals to plus or minus 1. Therefore, it is non-singular matrix. It is a non-singular matrix. But in this case, there is no conclusion for normal. It is an argument. Right? Suppose you take a real symmetry matrix. A is a real symmetric matrix.
Sir, a doubt, sir.
Yeah, tell me.
Unitary matrix.
Hello?
Hello.
Hello?
Hello, sir.
ఇప్పుడు చెప్పండి.
Unitary matrix, normal matrix, if and only if condition అనొచ్చా sir? Unitary అయితే normal అయితే unitary అవుతుంది sir.
See, unitary matrix is always a normal matrix. Normal matrix may not be unitary. ఇక్కడ ఎంత ముందు చూడండి. ఈ ప్రాబ్లం చూడండి. Just look at this problem. Yeah, this problem. ఈ ప్రాబ్లం చూడండి. ఈ ప్రాబ్లం చూడండి. ఇది నార్మల్ మ్యాట్రిక్స్ అయింది కదా. ఎలా ఎస్ఆనో?
Yes sir.
బట్ ఇది యూనిట్ అయిద్దా? ఇది ఐడెంటిటీ మ్యాట్రిక్స్ అయిందా? ఏంటి ఐడెంటిటీ మ్యాట్రిక్స్ అయిందా?
No sir.
కావాల్సిన అవసరం లేదు కదా. సో దెర్ఫోర్ యూనిటరీ మ్యాట్రిక్స్ ఇస్ ఆల్వేస్ నార్మల్ మే నాట్ బి యూనిటరీ. కావచ్చు కాకపోవచ్చు. సపోజ్ యూ టేక్ ఎనీ ఐడెంటిటీ మ్యాట్రిక్స్. ఇప్పుడు ఇదే కేసు తీసుకోండి, లాస్ట్ కేసు. ఇప్పుడు ఇక్కడ చూడండి, ఏ కోస్ట్ ఐడెంటిటీ మ్యాట్రిక్స్ తీసుకుందాం. ఏ ఇంటూ ఏ టీటా ఏమొచ్చింది? ఐ వచ్చింది. ఏ టీటా ఇంటూ ఏ ఐడి వచ్చింది. దెర్ఫోర్ ఇట్స్ ఇన్ దిస్ కేస్ ఏ ఇస్ యూనిటరీ ఆల్సో. ఏ ఇస్ యూనిటరీ, ఏ ఇస్ నార్మల్.
Okay.
ఓకే, ఇన్ జనరల్ కావాల్సిన అవసరం లేదు. అయితే కావచ్చు లేకపోతే లేదు, అకార్డింగ్ టు ద మ్యాట్రిక్స్ విచ్ ఇస్ గివెన్. Suppose A is a real symmetric matrix. Now, normal matrix, is it normal matrix? Does A is normal matrix? Doesn't mean that it's normal. So A is real symmetric. What is the meaning of this? A real means what? A bar is equals to conjugate of this is equals to itself. What is symmetric? A transpose is equals to A. You are given this. Now my question, is it normal? A into A theta. Compute A into A theta and A theta into A. If they are equal, then it's a normal. Otherwise, it's not normal. So A into A theta. What is the definition of A theta? Transpose of A bar. Therefore, what is A bar? A bar is itself because A is real matrix. A transpose. Therefore, what is A transpose? A transpose is equals to A because A is symmetric. This is nothing but A square. Similarly, A theta into A. What is this? A bar whole theta into A. But what is A bar? A itself because A is real. Therefore, what is A transpose? A itself because A is symmetric. Therefore, this is nothing but A square. So both are same. Therefore, it's normal. So real symmetric matrix is always normal. Real symmetric matrix is normal. Is it converse true? See what you observe, real symmetric matrix doesn't mean that it converse true. Anybody? Doesn't mean that it converse true. Suppose you take this example, 0 1 minus 1 0. We have seen it is a normal matrix. We have seen just now we have computed for the, I think it is a first problem, second problem. We have seen it is a normal, right? Is it symmetric matrix? No, right? Is it symmetric? What is A transpose? 0 1 minus 1 0. Right? It cannot be A itself. Therefore, it is not a real symmetry. It is real okay, but not symmetric. So converse may not be true. Right? Converse in general may not be true. It's an example. So normal matrix may not be symmetric. Right? Suppose you take a real skew symmetric matrix. Real, A is a real. A is real skew symmetric matrix. Question is that, is it normal? Doesn't mean that A normal. What is real skew symmetric matrix? Real means A bar is equals to A. Skew symmetric means what? A transpose is equals to minus A. Now compute A into A theta. A into A bar whole transpose. That is nothing but A into A bar is nothing but what? A bar is nothing but what? A itself is A transpose. A into what is A transpose? Minus A. A into minus A is nothing but minus A square. Similarly, compute A theta into A. That is nothing but A bar whole transpose into A. A bar is nothing but A. Is A transpose into A. But A transpose is nothing but minus A into A. That means minus A square. Both are same. Therefore, it is normal. It is normal. Does it mean that actually converse true? So what you observe? Real symmetric matrix, real skew symmetric matrix is always normal. What about the converse? What about the converse? Just now we have seen, look at this 0, 1, minus 1, 0. We have seen it is a normal. Right? Yeah, it is actually converse also true in this case, but look at the different example. Look at different example. So it is now work for actually converse, right? So it is normal also. Now try to give another example. Try to give another example. Suppose you take this 0, 1, 1, 0. You take this. It is a normal, okay, but not skew symmetry. Why this example not works? Because it is a skew symmetric matrix. A transpose is equals to minus A, right? Is it A transpose equals to minus A? You can check, right? It is not skew symmetry. What is A transpose? A transpose is equals to 0, 1, again 1, 0. It's not equals to, this is actually what A, but it cannot be minus A. Therefore, it is not skew symmetric. So converse in general may not be true. Right? Now suppose you take the Hermitian matrix. You take Hermitian. A is Hermitian. Does it mean that it is normal? Hermitian means, what is Hermitian definition? Anybody? A theta equals to A. This is Hermitian definition. Right? So is it normal? What is A into A theta? A into A. That is equals to A square. Similarly, A theta into A. What is this? A into A. That is nothing but A square. Therefore, both are same. Therefore, it is normal. Now, Hermitian matrix is always normal. What about the converse? What about the converse? What about the converse? Look at this. Look at this. It is normal. Is it Hermitian? Is it normal? Is it Hermitian? That A equals to 0, 1, minus 1, 0. Is it normal? We have seen. Question is it Hermitian? A theta is nothing but A transpose itself. What is A transfer? 0, 1, minus 1, 0. Is it A? No. Therefore, converse in general may not be true. Right? Converse it not be true. Right? Now look at skew symmetry. What about skew symmetry? If you take A skew symmetry. Skew symmetry, not skew symmetry, skew Hermitian. Does it mean that A normal? What is skew Hermitian? A theta is equals to minus A. Therefore, A into A theta is equals to A into minus A. That means minus A square. Similarly, A theta into A is equals to minus A into A. Therefore, this is nothing but minus A square. So both are same. It is answer okay. That means skew Hermitian is always normal. Now give me in. Does it mean that converse true? Does it mean that converse true? Anybody? Converse. You've seen just now. Just look at the example which I've seen already. You've seen already. So look at this example. So already seen 2 plus 3i, comma 1, I 1 plus 2i. You've seen actually. What is this? You know it is normal. You've seen it is normal. Yeah. Now tell me, is it square mission? Anybody? Is it square mission? Hello. Square mission is only.
No,
Hello.
sir, no.
No, why?
sir.
Look, diagonal element same కావాలి square mission అయితే. Diagonal element same. So no okay, but diagonal element same గా ఏం కావాలి square mission అయితే?
Purely imaginary.
Yeah, purely imaginary or 0 plus. But ఇవి అవుతున్నాయా? కావట్లేదు. Caught it not. Square mission. Okay, converse arbitrary. So converse in general, non-arbitrary. Right. Next is you take the real orthogonal matrix. A is real orthogonal matrix. Does it mean that it is normal? Real orthogonal means A bar is equals to A. Orthogonal means A into A transpose into A equals to I. This is nothing but real orthogonal. Right? Does it mean that is it normal? Compute A into A theta. A theta is nothing but A theta whole transpose. But A into A bar is nothing but A itself because it's real. But A into A theta is nothing but I itself. Right? Similarly, A theta into compute this. Nothing but A bar whole theta into A. That is nothing but A into A transpose into A. That is nothing but I itself. So both are same. So it is yes. Right? Now my question, what about the converse? What do you observe? Real symmetric, real orthogonal matrix is normal. You've seen this. What about the converse? Just now, no? You've seen? Look at this example. 2 plus 3i. This example is 2 plus 3i, 1. Next, I comma 1 plus 2i. You know it is orthogonal. We have seen. Is it orthogonal matrix? No. Because what is it? Sum of the squares of the elements of any row should be 1 కావాలి కదా. Squares ఏమైతేమో 2 plus 3i whole square plus 1. It cannot be 1, right? Right? So therefore it is not orthogonal matrix. Right? Now look at unitary. If A is unitary, does it mean that A normal? Does it mean that A normal? Anybody?
Yes, sir.
Yes.
I,
So you always, because A theta into A equals 5. So always normal. What about the converse? You've seen just now. Unitary is always normal. Right? What about the converse? This example, same example. Converse may not be true. Converse may not be true. Example, A equals 2 plus I, 2 plus 3i, I 1 plus 2i. Right? Now, you know, yeah, with this normal is completed. Right? Next is yeah, ఇది వేరే కాన్సెప్ట్. టైం పర్మిట్స్. ఓకే, చిన్న ఒక డెఫినేషన్ చెప్పేది లేస్తాను. So next is black matrix. ఇది చాలా ఇంపార్టెంట్. బ్లాక్ మ్యాట్రిక్స్ డిటర్మినెంట్ లో క్యారెక్టరిస్టిక్ పాలినామియల్ లో ఇది చాలా యూజ్ అయింది బికాస్ షార్ట్ కట్ అనమాట. బ్లాక్ మ్యాట్రిక్స్. వాట్ ఇస్ నేమ్ బై బ్లాక్ మ్యాట్రిక్స్? Anybody? What do you mean by black matrix? A matrix partitioned into some small matrices. We need to write some a system of matrices. Each matrix is called black. Understand? Some system of matrices. Each matrix is nothing but black. Is known as original matrix known as black matrix. Example. Suppose you take this A equals to 1, 2, 3, 4. You know it is a 2x2 matrix. So can you write it into a black matrix? Yes. Suppose I can write this matrix as 1, 2, 3, 4. By drawing a horizontal line, parallel line, horizontal line and vertical line, we can get a partition. So partitions are denoted by, so partitions, that means matrix, that means black matrix can be obtained by drawing the horizontal and vertical lines. You know it is nothing but what? Black matrix, because I can write this matrix as A1, A2, where what is this matrix? This is where A1 is equals to, what is A1? 1, 2, A2 is equals to 3, 4. So you know it is a black matrix. Why? Because it is partitioned into a system of matrices. A1 is a matrix, A2 is a matrix. You know what is the order of this matrix? Black matrix? Anybody? What is the order of this matrix? Original matrix is 2x2. What is the order of the black matrix?
1/2.
1/2 or 2/1? 2/1, right? Suppose you take this 1, 2, 3, 4. So can I get another partition and another black matrix? Yes. By drawing vertical line, I can get another matrix, black matrix. This is A1, A2, where A1 is equals to 1, 3, A2 is equals to 2, 4. Right? Now, original matrix order is 2/2. What is the order of the black matrix? 1/2. Right? Now 1, 2, 3, 4. Can you get another black matrix? Yes. So by drawing this vertical line, again drawing a horizontal line. You know matrix itself. This is A1, A2, this is A3, A4, where A1 is equals to singleton matrix, A2 is equals to singleton matrix, singleton 2, A3 is equals to 3, A4 is equals to 4. Therefore, you know it is a matrix itself. Matrix itself is a black matrix. This is also 2/2. Right? Or else I can take another example. Right? Example number 2. A equals to, suppose you can take this 1, 2, 3, 4, 5, 1, 1, 1, 1, 1, like 6, 7, 8, 9, 10, 3, 3, 3, 3, 3. ఇష్టం ఏదైనా తీసుకోండి. Next, yeah, 1, 3, 5, 7, 9. It's a matrix. Right? It is a matrix. Now, by drawing horizontal and parallel line, horizontal and vertical lines, we can get a black matrix. You know, it is a black matrix. Understand? This is actually what? It's a 5 rows, 5 columns. It is actually 5/5 matrix. Yes or no? It is a 5/5 matrix. Right? By drawing a vertical line and parallel line, we are going to get a black matrix. What is a black matrix? Anybody here? A equals to A1, A2, A3, A4, right? What is A1? 1, 2, 1, 1. What is A2? 3, 4, 5, 1, 1, 1. Right? Next, A3 is 6, 7, 3, 3, 1, 3. A4 is nothing but 8, 9, 10, 3, 3, 3, 5, 5, 5, 7, 9. So, it actually original matrix is 5 by 5 matrix, but what is the order of the black matrix? Yeah. What is the order of the black matrix?
2 by 2.
2 by 2. That's it. Yeah, with this I conclude. So by tomorrow I'm going to start black matrix classification and square black matrix and upper triangle black matrix and lower triangular matrix. And then I can start the determinants. Then I go for invertible matrix. Then matrices are completed. Matrix theory is completed. Okay. Is there any doubt? Yeah. Is there any doubt?
Professor, start చేయనా?
Yeah, sir.
Okay.
Okay, sir.